What's poppin', dogs? It's Mr. Allen with some polar coordinates. We're going to be plotting these 4 different polar coordinates here in this video, and we're going to write an equivalent point with a different radius or angle. I've seen that on tests all the time where they ask you to write an equivalent one. So we'll practice both of those. But first here, polar form. What are these? What's this ordered pair mean? It is r comma theta, where r is my radius, the distance from the origin, and then theta is my angle of rotation. Okay? So for this first one here, which we will do in orange, we have a rotation of 7 pi over 4. That's rotating all the way around to this guy over here. Okay? Now, my radius is 5, so I can count out 5. 1, 2, 3, 4, 5. Oh my goodness, I was right on it. That's crazy. So there we go. That is 5 comma 7 pi over 4. So you got to think about both of them at the same time. Usually I'm trying to like gauge out on my radius and then I rotate around, or I look for that rotation, then I count it out. Whatever strategy works for you, go for it. But this is 5 comma 7 pi over 4. Cool. Now when it says write an equivalent point in a different ordered pair using a different radius or different angle, possibly both, how could we do that? Well, we could do a negative angle of rotation, right? So I could write this as, and I'll do this in neon, okay, so it's a little bit different, but I could just do 5 comma negative pi over 4, right? That would rotate it down to that spot. Good to go. Is there any other way that I could write this? Well, negatives, you'll see these negatives here in a little bit. The negatives reflected over the origin. So if I were to rotate 3 pi over 4 and then do a negative 5, that would land me in the same spot. So negative 5 comma 3 pi over 4 would also do the trick. These two are the same spot as that one right there. Negative rotation of pi over 4 with a radius of 5, and rotating, here I am, over to 3 pi over 4, but then reflecting across the origin. That one would work too. So there we go. Cool. Sometimes on tests, they'll give you like restrictions. For those, they'll say the angle needs to be between 0 and 2 pi, but the radius has to be negative, or like radius is less than 0. Or they might say between negative 2 pi and 0 for the angle, and the radius needs to be positive, and you have to figure it out. So there's only one correct answer in those situations. All right, next one here. We got the blue guy. 4 comma 11 pi over 6. Well, 11 pi over 6 is all the way over here, right? Whee! So 4 would be 1 less than where we were. I think it's right about here. Let's see. Here we got 1, 2, 3, 4. And this is all the way around at 11 pi over 6. Nice. 11. Can't forget the 11. 11 pi over 6. Cool. All right, equivalent forms here, guys. Equivalent forms. Well, we could do the same kind of strategy, right? We could say 4 comma negative pi over 6, right? Just rotate it down. Or we could do the other one we just talked about as well. We could rotate to, what would this be over here? This would be 5 pi over 6 and then negative 4 for my radius. So negative 4 comma 5 pi over 6. Cool. There we go, man. I like that. Couple down. Let's keep it moving. Let's keep it grooving. We got, negative 6. 3 pi over 2. Well, 3 pi over 2 is a quadrantal. That's all the way around here, right? And 6 would be, it looks like on this guy, this rung right here, whatever you want to call it. And then I would have to reflect across the origin. So I'd be chilling right up here, I think. 1, 2, 3, 4, 5, 6. So this right here is negative 6 comma 3 pi over 2. So again, the negatives just reflect us over the origin. And my drastically larger parenthesis was bothering me. Okay. So there we go with that one. Let's see what we can do for an equivalent. We could do, what, just pi over 2, right? So we could do 6. I'm going to run out of room. So 6 comma pi over 2. That would work, right? Pi over 2 for my rotation. 6 for my radius. Yay! We could do negative pi over 2 and reflect it. So we could do negative 6 and negative pi over 2. That would work too. Cool. I could even do, hold up, we can even just do negative 3 pi over 2 for my rotation. So we could say it would be 6 comma negative 3 pi over 2. I mean, the possibilities are endless, especially with coterminal angles. Just keep on rotating this thing, man. All right, last one here. Last one. We've got, oh boy, double negatives. Doesn't make a positive. I don't know, whatever. So we got negative 3 for my radius and negative 2 pi over 3 for my rotation here. So negative 2 pi over 3 would be over here, right? This is negative 2 pi over 3. And then negative 3 for my radius. So if I'm normally at 3, I'd have to reflect over, and I'd be right here. Very good. All right. So this right here is negative 3, comma, negative 2 pi over 3. Right? That looks good. I think so. 1, 2, 3. Rotate. This right here is 2 pi. Sorry. Yeah, 2 pi over 3. That's my 60-degree reference, my pi over 3 reference. And then I reflect over. Beautiful. All right, so what can we do for some equivalent points here, since we've been just going ham on those right now? We could do, what? Pi over 3 for my rotation, just positive 3 for the radius. So 3 comma pi over 3. That'll work. Anything else? I could do like a full-on negative rotation, right? What would that be? 5 pi over 3. So we'd have 3 comma negative 5 pi over 3. That works. Cool. A lot of different possibilities here. Again, they'll probably restrict you to either a negative radius or a positive radius, or restrict you to a negative angle between negative 2 pi to 0, or a positive angle of 0 to 2 pi. So one of those few there. But there we go. Introduction to plotting points in Polar. Kind of cool system. There's a whole lot of math that goes on with Polar. This is just the surface here. But get yourself a jacket, dogs, because it gets a little cold here in this unit. Polar. That's awesome. All right. Have a great day, guys.